In this video, we will see how to solve for critical numbers and inflection points using a shortcut table method. Here we have a question, y is equal to x e to the power minus 2x. How would you find the critical number? So using the first derivative test, we have to derive it, isn't it? We have to use the product rule, derive it. But there's a shortcut way to understand how the graph is behaving. Where is it having a maximum or minimum? We have to have a calculators for that. And also it is necessary to know the options. Now over here, this is question number 4, part 1. So you will have 4 options. Look into the options. Why we need these options is to understand what values can we start and stop in the table. Now, since over here it's half, I will go with the step of 0.5, which I'll show you in a minute. But usually the answers will be around a certain range. So take a smaller range. Now, what I'll do over here is mod 7 and type this equation. X, multiply it with e, that is exponential. You have to press shift and natural logarithm gives you exponential minus 2x. Here I've typed in the equation. We are just solving for one equation, so this one is empty. If you have the latest model, this option pops up. Just ignore that. Now, where do I start? I know the critical number over here is around half. And there is no critical number, other critical numbers. And since it's half, so I will just take about minus 2, say minus 2 is enough. And then I'll end it at 3. So what just happened is start and end values will start my x and y values. Sorry, the x-axis. Now imagine this, the x. I started at minus 3, so minus 3 will be the first point in the table. Then minus 2, minus 1, 0. I'll have 1, 2, 3. I think so I put minus 2. So I will have the value of minus 2, where the graph is from this table now. Now one more thing, before we finish, we just put the starting and the ending point. What is the step? At what intervals do you want the values of y? That means if I put step as 1, I will have minus 2, minus 1, 0, and so on. If I put this as 0.5, I will have an understanding of from minus 2, minus 1.5, minus 1, 0.5. I'll get an idea of even half, right? So I put a step of 0.5. Now look here, minus 2 is how much? It's negative 100, then it's negative 30. So let me just mark them up. Minus 2 is somewhere over here, it's negative 100, a huge value. Then it drops up to negative 30, and then it's negative 7. Similarly, you need to just plot all the points. And then what do we have? Negative 1, and then 0. And then it's increasing. So over here it was negative 1, and then this was 0, and then it increased over here at 0.5. And the next value, okay, over here you can see from 0, it went to 0.18, which is maximum, and then it's dipping down. Can you see? It's decreasing now. So after 0.1, it decreased to 0.13 something. And over here, it's very negligibly above the line. But I know the maximum was at half. And over here, it's almost 0. Can you see? It's almost 0. It is not exactly 0, but it is going so close to 0 as if there is an asymptote. So it is closing in and in. So if I just graph it up, if I connect these points, I get this idea something like this. The maximum is over here at half. So I can confirm the critical number is half. And what is happening? Where is it increasing? It increases from minus infinity till half, isn't it? So I can tell from minus infinity till positive half, it's increasing. And then it's decreasing, isn't it? The values were decreasing. Though it was negligible decrease, it was decreasing. You can try more as well. And I can tell from half till infinity, it's decreasing. And the local maximum value is at half. X is equal to half. So this is what we can infer from this graph. And now we'll just compare over here. You can see this particular equation is increasing from minus infinity to half. Yes, it matches. Now, whichever option matches very closely to this may not be 100% accurate, but it'll give you a very close answer, right? You can easily choose it because it's the question number 4. If it was the writing part, we have done in detail for the related rates how to do it. But this one, here you can use this trick by the table. I've taken a long time because I was going in detail, but once you understand the trick, you can easily try it by yourselves and do it a lot more quicker. Now we will see one more problem because some of the students asked me about this problem. Here, this problem is also similar to what we did just a while ago. But let us solve this because over here the domain, it's a rational function. So the domain will be undefined at 0. So first you need to write the domain. Domain of x is all real numbers, but x cannot be equal to 0. Why? Because when x is 0, it's undefined, isn't it? So just keep that in mind. And then let's take our calculators and let's graph it up. Here we need to know the knowledge of the answers as well because you will have the options. Let's look into it. It's 0 and over here. Some other options might be -1, 2 and others. So let's go to mode 7. Let's type this equation now. X plus 1 divided by x. That's it. Now there is no option over here. Just press equal to. No equation over here. Just press equal. Let's start at say -3 and let's end it at +3. And the step I will give 0.5 so I'll have a better understanding of how the graph is moving. So now these are the values, right? Let me just plot a small graph. It's a rough graph. -3 over here, +3 here. Let's say -2, -1, 0, 1, and 2. Now here at -3, I know it's at -3.33, which is very down. And then at negative -2.5, you can see it's coming up. It's up over here. Let's go a little closer now. Here you can see at -1, -1.5, it is 2.16. And it is again increasing. But now what happened? At -0.5, it fell down. Okay? So it came up, increased, but at once it fell down, right? So if you take the step as 0.25, you will see it's going downwards. And that is okay because why? It is rational. So this happens. Now what about the other part? What happens at 0? See, at 0 you get an error. This means it's undefined over here. Why? Because x cannot be 0. It's undefined there. So the inflection point can never be 0. But let's see the right side first. Here we have 2.5, then we have 2. So at 0.5, it is 2.5, it's up. It's decreasing. At 1, it's coming down. And here you can see it came down here, but then again it's picking up. And let's see the more other values. Over here, we can see it's increasing again. So all the others are increasing. So it's similar, it's symmetrical. Now it's something like this. This is just a rough sketch. Now we can see error is there at 0. So this is an asymptote. It always goes near, but it never touches that line. So this is an asymptote over here. And this is how the graph looks, isn't it? Now here you can tell where is the concavity. How is it concaving? From 0 to infinity, it's concaving upwards, isn't it? See, it's upwards concave. Whereas over here, left side, from -infinity to 0, it's concaving downwards. And the inflection point is not 0. Why? Because it's undefined at 0. Where the point changes the concavity. See now, for example, if it was like this and this is like this is the point where it changes the concavity. But from this graph, you can see they're not at all touching each other. So there is no inflection point whatsoever. There is no inflection point. X cannot be equal to 0 and there's no inflection point. Only if they were touching something like this, then I could have said over here, this is the inflection point because over here it's concaving down, over here up. Here it is not at all touching each other, so there is no concavity. So from this stable method, you get a better understanding and you can easily check this. So if you're thorough with the derivatives, go ahead. Otherwise, you can easily graph it. It'll take you a few minutes. That's it. The time you derive this, you can do this. Just graph it up, get an understanding. You can just plot some random points, no need of accurate points, and do it. Now, the problem is if you don't take zero point 0.5 or 0.25, then it's a little bit hard. So try to understand, analyze the options, and try to take the step of zero point 0.5. It'll be much better. So that is how we can easily solve these problems using the table method.